Hi, this is David Voss, CCIE 11372, and in this video you're going to learn about RIP Design. Specifically, we're going to first learn about RIP version 1 so you can lay a foundation for understanding RIP version 2. Since that is the version most commonly used today, and if you were to design a network using RIP, most likely that would be the version you would choose. So let's begin with RIP version 1. Now, the major drawback of RIP version 1 and why many don't use it today is that it has classful behavior, meaning that it does not send back subnet mask information. Now, if there is no subnet mask information in the updates, then it assumes that any network is staying within its class-full boundary, which, as you know, in most networks today, that's rare. As you can see here, each class has a range of IP addresses that it would support. And if it were to remain on classful boundaries, that would mean that you would not be able to provide VLSM or break down these assigned subnets into smaller subnets. So for example, if you were assigned a network in the Class A range, let's say a 10 dot network, you would not be able to break your 10 dot network down into smaller subnets. So later in this video we will talk about auto summarization, and that if it summarizes on a classful boundary, specifically with 10 dot networks, you can have routing problems. So often you will find that you will want to turn off auto summarization in RIP version 2. Another issue with RIP version 1 is that it broadcasts updates. So it uses unnecessary bandwidth, but it also means that routers that are not even running RIP will constantly receive RIP updates even though they won't process them, because routers that run RIP will broadcast them out all interfaces. Modern routing protocols use a multicast approach in order to solve this issue by sending updates only to routers that really need to receive them. RIP version 1 does not allow authentication, so there is no element of security that can be added to the routing protocol to ensure that it is not sending information to devices that should not receive it. When examining RIP version 2, you can see that many of RIP version 1's shortcomings have been addressed. RIP version 2 has a classless behavior, meaning that subnet mask information is sent in updates so VLSM can be achieved. RIP version 2 also supports authentication to ensure that the person you are sending the information to is the person authorized to receive that information. Now, in addition to plain text passwords, the Cisco implementation provides the ability to use MD5 authentication. MD5 is a hashing algorithm that takes a variable length string of text and produces a fixed length 128-bit output. The advantage of hashtag plain text is that the original message cannot be reconstructed even with the knowledge of the hash algorithm. Now, with regards to advertisements, RIP version 2 multicasts routing updates instead of broadcasting them as RIP version 1 does. So this allows for the efficient exchange of routing updates. Another special feature of RIP version 2 is automatic summarization feature, which is applied to prefixes on classful boundaries. This behavior is a double-edged sword because it can induce problems in real-world scenarios. Let's look at the following example. Router 1 connects to the following networks: 10.10.10.0 and 10.10.20.0 and 10.10.30.0. Router 1 connects to router 2 and then on to router 3, which has connectivity to the 10.40.0 and 10.10.50.0 networks. There are also other networks between the routers, such as 172.16.0.0 and 192.168.0.0. Notice the change in classful boundaries that makes RIP automatically summarize the networks behind router 1 and router 3 as 10.0.0.0/8 toward router 2. This can lead to a problem, or it will lead to a problem. Router 2 will receive the same route from both directions. If it receives a packet destined for 10.10.10.0, It can send it in both directions based on the automatically summarized prefixes it received. This problem is called discontiguous subnets, and it's generated by the automatic summarization behavior of the routing protocol that aggregates those subnets. Solutions for this problem involve not using discontiguous subnets in different areas in the network topology, or disabling auto summarization. Let's take a look at the RIP version 2 message format. The RIP version 2 message format takes advantage of the unused fields in the RIP version 1 message format by adding subnet masks and other information. Let's go through some of the key attributes of this message. The command field indicates whether the packet is a request or response message. The request message asks that a router send all or part of its routing table. Response messages contain route entries. The router sends the response periodically or as a reply to a request. Version specifies the RIP version used, 2 for RIP version 2 and 1 for RIP version 1. AFI field specifies the address family used. RIP is designed to carry routing information for several different protocols. Each entry has an AFI to indicate the type of address specified. The AFI for IP is 2. Route tag. Route tags provide a method for distinguishing between internal routes, which are learned by RIP, and external routes, which are learned from other routing protocols. You can add this optional attribute during the redistribution of routing protocols. IP address specifies the IP address of the destination. Subnet mask contains the subnet mask for the destination. Now, if this field is 0, no subnet mask has been specified for the entry. Next hop indicates the IP address of the next hop where packets are sent to reach the destination. And metric indicates how many router hops to reach the destination. The metric is always going to be between 1 and 15 for a valid route, since 16 would indicate an unreachable or infinite route. Another aspect about RIP that you need to know is that it relies on a series of timers for its operations, as described here. The update timer, this is where updates are sent, and they're sent every 30 seconds by default. Invalid, the route is invalidated if no update was received before this timer expires. Flush timer determines the time a route gets flushed from the RIP table. And hold down timer. Updates are not accepted for a route that keeps getting a bad metric. And finally, the sleep timer, which can add delay to triggered updates. The hold down and sleep timers are Cisco specific and are used to enhance the RIP functionality. They were not originally specified in the RFCs for RIP. In summary, here are some key points about RIP version 2 that you need to memorize for your CCDA exam. It's a distance vector protocol which uses UDP port 520. It does not scale well since the maximum hop count is 15. Periodic route updates are sent every 30 seconds to a multicast address. 25 routes are allowed per RIP message, or 24 if you're using authentication. And obviously it supports authentication. Subnet mask is included in every route entry. It's a classless protocol. It does support VLSM, and the metric for RIP version 2 is router hop count. Now, all of these points you need to memorize for your CCDA exam. This video has given you a good base foundation for preparations for your CCDA. If you can memorize what you've learned in this video, you should do very well when asked questions about RIP and how and when you would use it in a network design. Good luck in your studies.